Jumping right over here to section 3.3, just wanted to review some rules. If you already remember all of your derivative rules, power, product, constant, and quotient, then go ahead and fast forward the video until you get to the problems down here in the bottom. I do have one problem down here in the bottom that I'm going to show you how to do. But just a quick review of our derivative rules. The power rule says that you take the power when you're taking the derivative of x to some power, then you take the power, bring it out front, and then subtract 1 from the exponent. The product rule says that the derivative of a product, uv, so u and v in these cases here are functions of x. So they're not constants, they're functions. So we have the first times the derivative of the second plus the derivative of the first multiplied by the second. And I chose x and e to the x because the derivative of e to the x is the same as e to the x. And then derivative of x is 1. So we have the first times the derivative of the second plus the derivative of the first, which is 1, multiplied by the derivative of the second. And so that would be the derivative of x times e to the x. Quotient rule, we know that the derivative of the quotient of u and v would be v u prime minus u v prime over v squared. I think low, and I don't know if you learned it this way, if you had me you did, low d high, high d low. Of course over low squared. So if you remember low d high d low, and the minus sign in between, that's just the way I remember it. So the derivative of this quotient here would be low, which little low would be underneath the division bar or the denominator. Low d high, so multiplied by the derivative of the numerator, minus the high, in other words the numerator, multiplied by the d low or derivative of x cubed, which would be 3x squared. And that's all over low squared, so x cubed squared. I'll leave the simplifying to you guys. And then the constant multiple rule, I should have just used a u or a v here, so the derivative of a constant times a function would be the constant times the derivative of the function. But the way we normally do it is we just usually take the 4 and multiply it by the 3. If we're taking the derivative of 4x cubed, then we know that that's 3 times 4, or 12x to the 3 minus 1, or x squared. Okay. So it does come in handy, though, when we take the derivative of, let's say, some sort of a constant like 4 multiplied by two complicated functions, e to the x, I know it's not complicated, but let's say e to the x minus 4 multiplied by, I don't know, like sine of x, let's say. And we might want to bring that 4 out and then just concentrate on the derivative of what's left over. Okay, so that's when you do need to know that you can do that, and that's very important. Okay, so I don't want to leave that out. And sometimes what you're taking the derivative of, you can factor out. I said basically twice, now 3 times. So you're taking that 4, that factor, out of and simplifying the derivative process. Okay, so that being said, let's take a look at what types of problems that you'll see in AP Calc. I didn't write a couple other things that lead up to this particular problem, but the couple other things I'm talking about are that u and v are both functions of x, and they also, the derivatives exist at 0. And so that's really basically all you need to know here, is that this function is differentiable at x equals 0, which means it's continuous there, and we can calculate the derivative of this product. Okay, well, it might look like it's kind of funky, maybe a little bit intimidating when you see all the letters. These are more general questions, testing your ability to understand the concept versus can you do a problem that has a bunch of numbers in it, maybe numbers and variables. But when you're given information or problems like these, you're really just being tested on, do you understand conceptually what it is you have to do? And so we're just going to test your ability to understand the derivative of a product. And we know that the derivative of a product, we know the rule is the first times the derivative of the second plus the derivative of the first times the second. Okay? And the derivative of uv, now I didn't write this, but what we're really trying to find out here is what's the derivative of uv at 0 when x is equal to 0. So the way we'll do this is we'll just write this u of 0 times v prime of 0, okay, plus u prime of 0 times v of 0. Okay, and we know what u of 0 is. It says it right here. U of 0 is 5. And v prime of 0, we just have to write that in. That's 2. Plus u prime of 0 is negative 3. And v of 0 is negative 1. So we have 5 times 2 is 10. Plus negative 3 times negative 1 is 3. So we get 13. So 13 is the answer. So many times these problems can be pretty easy as long as you know what to do, and I'll say that all year long. I get sick of myself saying that. As long as you know what to do, it's actually not that much work and it's fairly simple. So if I could get you to do this, go ahead and pause the video and try this next one. And I'll just keep going. Low, and I'm going to write the 0 also. I'm not going to do this extra step. D high, so that's multiplied by u prime of 0, minus the high, u, which is u of 0. And again, we're trying to figure this out at x equals 0. Multiplied by, so we have low d high minus high d low, so v prime of 0. And then all over low squared, so v of 0 squared. And then we just substitute in the values. V of 0 is negative 1. U prime of 0 is negative 3. Minus u of 0 is 5. And v prime of 0 is 2. All over v of 0 squared. So v of 0 is negative 1. And negative 1 squared is going to be 1. So that denominator is going to be 1. And let me write that. Equals 1. So we have 3 minus 10 over 1, which is just negative 7 over 1. So negative 7 is the answer that you should have gotten. That's it for that section for the time being. You know, I have a little bit of time here, so let me do this next problem. No, what I'll do this. I'll write it out, and then you won't have to sit through me writing out the problem.